Hello friends, Standard 11 Chemistry, Unit 1, Some Basic Concepts of Chemistry, Part 11. In 10th part we learn empirical formula, molecular formula and structural formula. Well, for example, here a molecular formula H2S2O8. It is called peroxy disulfuric acid. Here the elements are hydrogen, sulfur and oxygen, and its proportion 2 is to 2 is to 8. We can write here 1 is to 1 is to 4. And from this proportion we can write the empirical formula for hydrogen 1, sulfur 1 and oxygen here 2, and integral number is 2. So this is the empirical formula for peroxy disulfuric acid. Okay, now the another example, NH6P6O18. This is called sodium hexametaphosphate. Here the elements are sodium, phosphorus and oxygen, and its proportion is 6 is to 6 is to 18. 6 will be common, so we can write here 1 is to 1 is to 3. From this proportion we can write the empirical formula Na, P and O3. 6 is will be our integral number. Okay, then after we learn the percentage composition. The percentage of element equal to mass of that element in compound multiplied by 100 divided by molar mass of compound. From this equation we learn some examples. Let's see the another example regarding this formula. Have a look at this example. Percentage of element M is 53 in its oxide of molecular formula M2O3. Calculate atomic mass of M. M, that is XYZ element, that we have no any other information, but we have the percentage of M is 53. What about the percentage of oxygen? Here M and O, two elements, and its total percentage is 100. So from this equation we can write here for oxygen 100 minus 53, oxygen percentage is 47, that we can calculate very easily. But here we have to find the calculate atomic mass of M. We have another data, that is M2O3. This is the oxide, or we can write here it is taken as our compound. So we have to find molar mass of M2O3. Here 2m plus 3 of oxygen. Atomic mass of M, we have no data, that's why we can write here m. For oxygen, atomic mass is 16, twice m, plus 3 multiplied by 16, that is 48. Okay, so we have the molar mass of M2O3 twice m plus 48. Now we have the formula of percentage of m equal to mass of m multiplied by 100 divided by molar mass of M2O3. Percentage of m is 53. Mass of m here twice m multiplied by 100, and molar mass of M2O3 twice m plus 48. Here the cross multiplication, therefore 53 into bracket twice m plus 48 equal to, here twice m multiplied by 100 equal to 200 m. Therefore 53 multiplied by twice m 106 m plus 53 multiplied by 48, that will be 2544 equal to 200 m. Therefore the simplification, 200 m minus 106 m equal to 2544. Therefore 200 minus 106, 94 m equal to 2544. Therefore m equal to 2544 divided by 94. Therefore m equal to, it will be 27.06. it is nearly about 27, so that's why our answer will be 27. So here from this data, percentage of m or any elements, that we can find the mass, atomic mass of any elements. Okay, let's see another example. Here the another example, in MO3 type of oxide, percentage of m is 40. Calculate atomic mass of m and its molecular formula MF. Okay, same thing here. We have the compound MO3 and percentage of m equal to 40. We have to find molar mass of MO3 equal to m plus 3 of oxygen, m plus 3 of 16, therefore m plus 48. Molar mass of MO3 is m plus 48. Percent of m equal to mass of m multiplied by 100 divided by molar mass of MO3. Percentage of m 40. Mass of m, here mass of m is only m multiplied by 100. Molar mass of MO3 m plus 48. Cross multiplication, therefore 40 into m plus 48 equal to m into 100, 100 m. Therefore 40 m plus 40 multiplied by 48, this will be 1920 equal to 100 m. Therefore 100 m minus 40 m equal to 1920. Therefore 60 m equal to 1920, therefore m equal to 1920 divided by 60, 0 will be cancelled, and 6 3s are 18 and rest of the 12. So here m equal to 32. The atomic mass, this is the atomic mass 32. Atomic mass is 32. As we discussed earlier that every element has particular atomic number and atomic mass. Suppose here for sodium atomic number is 11 and its atomic mass is 23. So sodium has specific atomic mass, and same thing is here, the atomic mass is 32. The elements is sulfur, which can sulfur that can, its atomic mass is 32. So from this data we can write here the molecular formula MF. MO3 that we have found sulfur atomic, from this atomic mass sulfur SO is identical SO3. This is the our molecular formula. It is called sulfur trioxide. Okay friends, so any other elements you can write here. Suppose M3O4, suppose you will be given in this, in the examination, you can found from this formula. This is the another example, try yourself. In MH2 type of compound, percentage of M equal to 24.27, calculate its atomic mass of M and write its molecular formula. Now let's see the another type of example, that is regarding to we have to find empirical formula and molecular formula from percentage of element and molar mass of compound. Only the data will be given, the percentage of elements and molar mass of compound, and from this data we have to find the empirical formula and molecular formula of the particular compound. For this topic we have to follow some steps. First of all, for find out empirical formula, we have the observation table number 1. Then after, for finding the molecular formula, we have 4 another steps. Number 1, find empirical formula. This data will be find from this table. Number 2, then calculate empirical formula mass. Number 3, integral number, that is denoted by small n, equal to molar mass divided by formula mass. In short, here we can write small mm and empirical formula mass. Then after, step number 4, for molecular formula mf equal to integral number multiplied by empirical formula ef. In short, we can write here em. So we have another two formula is very most important. To find out the empirical formula and molecular formula, step for finding of empirical formula, number 1, table, and for finding the molecular formula, find empirical formula, calculate empirical formula mass, integral number n, and molecular formula. Let's see the table. Here elements, then after its percentage atomic mass, then after percentage, then after atomic ratio will be found equal to mass divided by atomic mass. Then after ratio of whole number, and last column simple or into bracket whole number. Okay, from this table we find the empirical formula. Let's take another example. Here the example, percentage of carbon 54.55, percentage of hydrogen 9.06, percentage of oxygen equal to 36.39. Find empirical formula and molecular formula. Molar mass of organic compound is 88 gram per mole. First of all, the steps for finding of empirical formula. Elements, their atomic mass, then after percentage, atomic ratio equal to mass divided by atomic mass of element, then after ratio of simple whole number, and then after simple or whole number. Elements are here carbon, and its percentage is carbon, and its atomic mass is 12. The percentage 54.55. Then hydrogen, its atomic mass is 1 and percentage 9.06, and its oxygen atomic mass 16 and percentage is 36.39. For atomic mass ratio, mass divided by atomic number. Now what about the mass? The percentage of mass, that will be your mass of particular element, 54.55 divided by atomic mass is equal to 12. This will be 4.55. Then after 9.06 divided by 1 equal to 9.06. Here the mass 36.39 divided by 16, this will be 2.27. Now for this column, ratio of simple number or whole number, for this value, this is the smallest value, and by this value all these value can be divided. 4.55 divided by 27 equal to round about 2.0. 9.06 divided by 2.27 equal to 3.99, and 2.27 divided by 2.27, this will be 4. So for this column, this is the smallest number. This smallest number is taken to find the ratio of simple number. Now the last column, simple or whole number, this will be 2. 3.99, it is nearly about 4, and here 1. So empirical formula equal to carbon C2, hydrogen is 4, oxygen will be 1. Okay, this is the first step. Now for molecular formula, we have to find the next step, that empirical formula mass. Here the empirical formula, twice C plus 4 H and for oxygen. Empirical formula is same as molecular mass. Carbon 12, 4 of hydrogen 1, and for 16 oxygen for 16, 24 plus 4 plus 16 equal to 44 gram. Formula per weight. This is only the difference between molar mass. Here the molar mass we can write here gram per mole, and here empirical formula mass gram formula per weight. This is only the difference between mass. Now our third step, to find the integral number small n. Integral number equal to molar mass that is given and divided by formula mass. Molar mass is 88 and formula mass that is 44. 88 divided by 44 equal to 2. Our integral number is 2. Number 4 step, find molecular formula. Molecular formula equal to integral number into empirical formula. Integral number 2 and it's our empirical formula, that is C2H4O multiplied by 2, C2 C4, 2 multiplied by 4 8, and here we considered only 1, so O2. Our molecular formula is C4H8O2. So you can write here for N directly molecular formula MF equal to molar mass mm, formula mass Fm, empirical formula mass EFM, empirical formula mass or Fm multiply by empirical formula. Let's see another example here. Determine empirical formula of an oxide of iron which has 69.9% Fe and 30.1% dioxygen by mass. Determine the empirical formula only. We have the data for Fe 69%, 9%, 69.9% by mass, that means weight by weight. That from this data we can write here 69.9 gram, and percentage of oxygen equal to 30.1% weight by weight. From this data we can write here 30.1 gram. Okay, and total that is 100%. Okay, for empirical formula we have to follow the table. Let's see here. First of all, elements, then after its atomic mass and their percentage, then after atomic ratio equal to mass by atomic mass, then after ratio of simple or whole number, and then after simple or whole number. Elements are number 1 Fe, its atomic mass is 56, its percentage 69.9, atomic ratio mass 69.9 divided by atomic mass is 56. From this data, this will be 24. Ratio of simple number that we can calculate after this: oxygen 16, percentage 30.1, atomic ratio 30.1 divided by its atomic mass of oxygen 16 equal to 1.88. Now you can calculate the ratio of simple number. From this data, 1.24 and 1.88, this is the least value, so we can divide by this value. 1.24 divided by 1.24, this will be equal to 1, and then after 1.88 divided by 1.24. So for this ratio of simple number, we have to divide the least number. 1.88 divided by 1.24, this will be 1.5. Now for simple whole number, here the simple we can write here 1 is equal to 1, but here 1.5, what will be our simple number? Either it may be 2 or 1, because it is 1.5. So we need the particular multiple that gives you the simple number. That means here, suppose here 1.5 multiplied by 1 equal to 1.5. 1.5 multiplied by 2, that means 3.0. This is the our simple number. So here it is multiplied by with 2. That's why, because of this multiple is multiplied by 2, we can multiply here 1 multiplied by 2, this will be 2. Okay, now this is the simple number. Empirical formula equal to Fe 2 O 3, Fe2O 3. This will be your answer. And this is the example of in your exercise 1.3. Try yourself another example. In hydrocarbon, carbon equal to 94.4%, hydrogen equal to 5.6%, its molar mass equal to 179 gram per mole. Find its empirical formula and molecular formula MF. Okay, try yourself. Let's see another example. Another compound contains 24.27% of carbon, 4.07% of hydrogen, and 71%, 71.65% of Cl is Cl is chlorine. Its molar mass is 98.96 gram. What are its empirical formula and molecular formula? Now the another example, empirical formula and molecular formula, molar mass, mm, that is molar mass of compound are CH2O and 180 respectively. What will be the molecular formula of compound? Options are A C9H18O9, B CH2O, C C6H12O6, and D C2H4O2. Here EF empirical formula is CH2O, molecular molar mass mm equal to 180. What will be the molecular formula? For molecular formula, m equal to integral number multiplied by empirical formula. For n equal to means molar mass divided by empirical formula mass multiplied by EF empirical formula. Now empirical formula for CH2O, 12 plus 2 plus 16, 80, this will be 30. So molar mass is 80, empirical formula mass 30 multiplied by EF CH2O, this will be cancelled out, and 6 multiplied by CH2O, means C6, 2 multiplied by 6 H12, and here O6. So molecular formula is C6H12O6. Answer is C. Okay friends, so next time we will discuss another topic, that is limiting reagent and stoichiometry of chemical reaction. Thank you very much.